Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at adding linear expressions. So the main goal for this video is how do I add linear expressions? Well, to start, we want to know what a linear expression even is. It is a type of algebraic expression in which each term is a constant or the product of a constant and the variable is raised to the first power. So really that's the important part right here, is that the variable is raised to the first power. Because there are other types of algebraic expressions. There are ones that are going to have an exponent that's squared or cubed, and those are not considered linear. So a linear has a variable raised to the first power. So again, that's the piece that's going to be important for us here. Note, when simplified, a linear expression cannot contain a variable in the denominator of a fraction. So to kind of quickly run through, again, a linear versus what we'll call right now a nonlinear expression, we have some examples that are already given to us in this table. An example of a linear expression would be 5x because, again, it has a product of a constant, so that coefficient, and a variable raised to the first power. Or again, we have a combination of, again, we have this variable term, again with the variable to the first power, and then we have the constant hanging out on the end, which is totally okay. But the big thing here is that, again, those variables are to the first power. The nonlinear expressions, we have two variables going on, mn, that's not linear. Then we have this variable here that's being raised to the fourth power, again, that's making it not linear. So if I take a look at this first one, this negative 5x squared, that is going to be considered non-linear because the x is being raised to the second power. So that is a non-linear expression. The next one, negative 4x plus 3, that is considered linear because the variable is being raised to the first power. So this one's good to go and being linear. The half x minus 5, also a linear expression because, again, that variable is being raised to the first power. Then we have this 6 over x, and so this is where that second portion of our definition comes into play. We can have a variable in the denominator of a fraction because this kind of leads us into more of the 8th grade level, but this is the same as 6 times x to the negative 1. That's not to the power of 1, that's to a negative 1. And so that is making it a nonlinear expression. So that 6 over x is considered nonlinear. And the x to the third power plus 2, also considered nonlinear because, again, that x is being raised to the third power, not the first. So you just want to make sure that if you're ever asked linear versus nonlinear, linear expressions always have the variable raised to the first power, and there's only one variable, not two like we see on this one. All right, so moving into our examples on adding linear expressions. In these ones, we're going to have just one variable going on. And the really nice thing about these is that you do have a couple of options of how you want to think through them. So I have, for my students, I tell them they can do a vertical method or a horizontal method when it comes to solving these. We can write this as 4x minus 2 plus, and then negative 7x minus 3, almost like we're doing long addition, right? And then we can just go through and say, all right, well, again, be careful here with that subtraction because technically these are saying these are negatives. We can say, all right, well, now I have a negative 2 plus a negative 3. That's going to be a negative 5. And we can actually just write it as subtracting 5. 4x plus a negative 7x is going to make a negative 3x. And so my final answer would be negative 3x minus 5. So this vertical method just allows us to line up our like terms, and then we just add those terms vertically. Versus the horizontal method. So this was, like I said, our vertical method. So essentially we line up those like terms and then just go from there. So with the horizontal method, essentially you can just drop the parentheses. So we can write this as 4x minus 2 plus negative 7x and then minus 3. And I say we drop parentheses, but I did put parentheses back around the negative 7x just to make sure I'm not losing track of that. And then I will clean this up by writing this as plus negative, so that way I don't lose track of those negative signs. And then it just goes back to simplifying expressions. So combine your like terms. We have a 4x and a negative 7x. That's going to combine to make a negative 3x. Plus, then we have our next set of like terms, this negative 2 and a negative 3, which is going to be a negative 5. And then we can just rewrite this so that it is simplified all the way. Negative 3x plus negative 5, that's the same thing as negative 3x minus 5. So a lot of students like the horizontal method. because it's just like what we've been doing for a really long time in math, right? Just combine like terms. Vertical method can also be nice though, especially for students who are visual and they really like to see those like terms right next to each other. So again, whatever method works best for you. Maybe sometimes you use the horizontal method, sometimes you use the vertical. I tend to always use the horizontal method just because, again, it just goes back to what we've been practicing for a very long time, right? Which is combining like terms. So you'll see that I'll use that in a lot of the examples in this video. And this next one though, I will do a vertical setup as well as the horizontal. So again, you can see both. And then moving forward, I'll just do horizontal. So for the second one, it says find negative 3x plus 8 plus 6x minus 12. So again, if I was going to set this up vertically, I would have negative 3x plus 8. And then underneath that, again, I'll line up my like terms. And then we have that minus 12 there. So again, almost like you're setting up a long addition problem. I would rewrite that minus 12 as plus negative 12 just to be on the safe side so you don't forget that that is technically a negative there. And then we just add 8 plus negative 12. That's going to put me at a negative 4, so we can write that as minus 4. And then negative 3x plus 6x is going to put me at positive 3x. And so there's my answer when I write this out vertically. Horizontally, we're going to get the same exact thing. Essentially with the horizontal method, we're just going to drop the parentheses. So I'm going to write it as negative 3x plus 8 plus 6x, and then we have minus 12. I'll just clean this up a little bit by writing this plus negative so I don't hopefully forget that negative sign in there. And then we just combine like terms. So I have a negative 3x and a 6x. We also have an 8 in this negative 12. So combining like terms, negative 3x plus 6x would be a 3x. 8 plus negative 12 is going to be a negative 4. And then we'll rewrite that as 3x minus 4. So same answer, just a different way of thinking through the question. All right, more examples, but now involving some fractions. So we're going to do the same idea. These ones I'm going to just use the horizontal method, but remember you could line these up vertically. But we do need to keep in mind when we work with fractions, when we're adding or subtracting them, you need a common denominator. So I'm going to go ahead and rewrite this first one, the 1/3 x plus 9 plus the 5/12 x minus 4. I'm going to go ahead and write it without the parentheses. So we'll have 1/3 x plus 9 plus the 5/12 x minus 4. So with this question, again, we have those fractions. So we need a common denominator. Hopefully we're noticing that, yep, these two are the ones that are going to be combined because they both have our x variable attached to it. And then we also do have a 9, so our constants. And then this is technically a negative 4 that would be combined with the 9. For the 1/3 x and the 5/12 x, we do want a common denominator. So a great one to use in this case would be 12. So that means I'm multiplying the top and bottom of the 1/3 by 4 to change this into 4/12 x. And I'll go ahead and write the 5/12 x next to it. Plus we have the 9 plus this negative 4. So combining our two out front, the 4/12 x plus the 5/12 x, that's going to be 9/12 x. Plus the 9 plus negative 4, which is going to be 5. The only other step we have is to make sure that we simplify our fractions. So the 9/12 can be simplified. 9 and 12 can both be divided by 3. So if I write my work here, we're dividing each of these by 3. And that is going to give me a final expression of 3/4 x plus 5. So that is the final answer on that one. So same idea number 2, 6x plus 3/5 plus, and then the other set of parentheses, negative 5x minus 1/3. So we're going to go through and rewrite this without the parentheses, because again, I'm going to use the horizontal method. So we have 6x plus the 3/5 plus, and then negative 5x, and then we have the minus 1/3. I can rewrite this on the end here as plus negative. My two constants, which are fractions in this case, are the like terms, so they are going to be combined. We also have a 6x and a negative 5x that'll be combined as well. So if I rewrite this, 6x plus the negative 5x, so that those two like terms are next to each other. We also have this 3/5 and the negative 1/3. So a good common denominator in this case to use would be 15. So I'm going to be multiplying this one by 3 to both the top and bottom, this one by 5. So we're going to have 9/15 plus, this is going to be a negative 5/15. And then combining our like terms, 6x plus negative 5x is just 1x. Again, you don't need to write the 1 in front of it, so just x. plus the 9/15 plus a negative 5/15. We're going to subtract those since they're different signs and get 4/15. And that is my final answer for the second one. Okay, so some story problems. So the Drama Club is selling tickets for their latest production. They're also accepting additional cash donations. They plan to save 20% of the money from all ticket sales and donations for their spring trip. Ticket sales and donations from 2 performances are represented in the table, where T represents the cost of a ticket. If tickets cost $9, how much money will the Drama Club have available for the spring trip? Now, essentially with this question, yes, you could solve this without adding linear expressions, but it is less math in the end when you have a simplified expression to use. And so that's kind of the point of these two. Like we have this example and then another one with a story problem where the idea is that you're going to add the linear expressions together so that you can then solve part 2 to the problem in one step. So we have Friday night's tickets, so 92T plus the 109. 92T plus 109. And then we're adding Saturday night's ticket sales to that too. So the 34T plus 13. So step 1, we're going to add these linear expressions. Again, I like to just drop those parentheses, combine like terms. So we're going to have the 92T plus the 34T. So 92 plus 34, that's going to be 6, that's going to be 12, so 126T plus the 109 plus 13 is going to end up being 122. So that's my simplified linear expression. Okay, so that was step 1. Step 2 is going to be to now figure out, okay, tickets cost $9 a piece. So we're going to figure out, well, how much did they make if T, again, the ticket price, was $9? So we're going to have 126 times 9 plus the 122. So now just order of operations, we got to figure out what 126 times 9 is. So after we do that multiplication, you should have come up with 1,134. Then we're going to add 122 to that. And so now we get 1,256. Again, that is telling us how much money we made on the sales of those tickets and donations too. So they're now saving 20% of that amount. So we have one final step to solve this question. We're going to figure out what 20% of the 1,256 is. Now, multiplying is what we're going to do here. The 20%, rewrite that as just 2/10, so 0.2. multiplied by 1,256. So essentially, for your work, we're just doing 1,256 times 2. So we get 2,512. You're going to add 1 decimal place back in. And so my final answer on this is going to be $251.20. So that is how much money they are going to be saving for, or earning, I should say, from this drama production and what they're keeping from those ticket sales and donations. So very similar idea on this last one. It says Alberto and Dylan get a weekly allowance plus $C for each household chore that they do. They plan to save 60% of their combined earnings in 1 week to purchase a video game. Their earnings in a certain week are represented in the table. If their parents pay $8 for each chore, how much money will they have to purchase a video game? So we have Alberto's earnings, Dylan's earnings, and they're going to team up so that they can purchase this video game. So we need to, very similar to the last one, step 1, again, add these two amounts together. Now, as I already said in the previous example, yes, you can totally solve this a different way, but the whole purpose of this video is to add linear expressions. So that's what we're going to be doing in this one. So we're going to add this 10 plus 8C plus the 15 plus 3C. And again, essentially, we're just going to combine like terms. So ignoring those parentheses, we got the 10 and the 15 that are like terms. We have the 8C and the 3C that are also like terms. So the 10 plus 15, that's going to be 25. Plus we have the 8C and 3C, which is 11C. Or you can write 11C plus 25. Same thing. So that was step 1. We figured out our simplified algebraic or linear expression. Step 2 is to figure out, well, how much money did they actually get when they combined their earnings. So C is going to be 8, so $8 for each chore. So C is now going to be replaced with 8, and so we'll have 25 plus 11 times 8. So this will be 25 plus 88. And then adding that together, we're going to have 113, and again, dollars on the end of that one for our labels. So now they're saying, okay, we're going to save 60% of that to then buy this video game. So we need to figure out what 60% of 113 is. So 60% of 113. We're going to be multiplying. So 60% of $113 means you're going to be doing 6/10, so we just rewrite that percent as a decimal, multiplied by the 113. If we write our work out on the side, essentially you're doing 113 times 6. So that's going to be 18, right? 6, 7, 6. Add your one decimal place back in there, right? And so this is going to be $67.80. So that is how much they saved for this video game. And that's your final answer for that question. So hopefully this video helped you with adding linear expressions. Make sure you check out the one on subtracting if you need help with that concept. Thanks for watching.